All right, so here's our plan. Our plan is to go through triangular prisms today. That will be our last prism surface area. And then we're gonna look at pyramids on Monday. Next week, early next week, we'll be doing some review of just surface area, volume, vocab practicing, and you'll have a summative over 3D geometry towards the end of next week, most likely Thursday or Friday, okay? So, when we're looking at triangular prisms have triangular bases. So when we're talking about a triangular prism, it has two bases, both of which are triangles, and those triangles are the same size and shape. They're opposite from each other. They have the exact same measurements. So the first thing it tells you to do is to shade the base of the figures. So we're going to go ahead and shade. You can shade both triangles or just one of them on each of the shapes. But shade in the piece that's the base. Then, unlike rectangular prisms, there's not like a long formula that we can use because it's going to depend on what the rectangles look like. So we're just going to summarize this, and we're going to say that it is the area of our two triangular bases plus the area of our three rectangular faces. So go ahead and write that in your box for the surface area formula. You're essentially finding the area of the two triangle bases and adding the area of the three rectangle faces. All right, so let's run through some examples. We're going to start with the one on the left, the one that's drawn as a 3D shape. So we're going to start by finding the area of those triangular bases. So if you think back to when we first started geometry, I shared with you kind of how we abbreviate a lot. So I'm going to write A for area and then draw that triangle next to it to show we're finding the area of the triangles here. And because we have two triangular bases that are the same, we're going to multiply our area formula by 2. So to find the area of a triangle, who remembers the generic area of a triangle formula? Rex?
It's the base times the height divided by 2.
Base times height divided by 2. So if we look at this triangle, we have a base that's right here, that's 7, and a height of 9. So we're going to do 7 times 9 divided by 2, which gives me the area of the triangle. But then I'm multiplying it by 2 because there's two bases that are the same. So if you think about that, what's going to happen with the divide by 2 and the multiply by 2? They're going to cancel each other out. So we don't really need to, for this particular shape, we don't need to do in our calculator the times 2 divide by 2 because they cancel each other out. And essentially what we're left with here is 7 times 9, which is 63. I'm still writing them in because I want to show that yes, it's a triangle, so I have to divide by 2 to find its area. But I'm multiplying by 2 because there's two pieces that are the same there. Okay? Now what gets tricky about all of our shapes that have triangles, so triangular pyramids, triangular prisms, is depending on what kind of triangle we're using, it makes it harder or easier. So if we have an equilateral triangle, meaning all three sides are equal, that's the easiest place we can be. So if we look at this example, this bottom piece or base is labeled as 7, and these other two sides are not labeled with measurements. So we are assuming that all three sides are 7 and that's equilateral. If, and don't write this down, let's say that side was labeled 8 and that side was labeled 10, meaning my triangle had different side lengths. If all of my side lengths of my triangle were different, then all of my rectangular faces are also going to be different, which isn't a huge deal, but it's just going to be a little bit of extra work. In this case, the example it gave us, though, only the 7 is labeled, so we're assuming all three of these side lengths are 7, which means all three lateral faces are going to be the same. So for my rectangles, I have 3, and what are the length and the width of those rectangles? Looking at the drawing. Lily?
Would it be 9 times 9 by 11?
Not 9 by 11, one of those pieces we're using. Not 11, wait, what did you say? 7 by 11, yes, sorry, I thought you said 11 by 11. So the height of this prism is always going to be one of the side lengths, so it's 11, but then it's by that slant length, which is 7. So 11 by 7. The height, Lily, that you were looking at, that 9, if you look at the net over here, you can see that that height goes straight through the face. It's not actually one of the sides of the rectangle. Okay, so we've got 3 times 7 times 11. And that is giving us, thinking kind of this bottom rectangle and then the 2 side rectangles, 7 by 11. So 3 times 7 times 11 is?
21 plus 33.
You're thinking distributive property. We just want to multiply straight through there. 7 times 3 times 11, which is 2 what? 231. 231. And then our final piece here is to get the total area. So we're going to take the area of those 2 triangles, which were 63, plus the area of our 3 rectangles, which were 231, to give us a total area of 294 meters squared. Bless you. Anyone have questions about where any of those numbers came from? Oh, move it up so you can see it a little bit better, get it copied. Take a look back at the numbers you have. If you have a question about where something came from, let me know. Whoopsies. We good on that one? All right, we're going to jump over then to example 2. And we're going to start the same way. So looking at those triangular bases, there are 2 of them. So I'm going to multiply 2 by, what are the base and the height of those triangular base, or those triangular, I guess, bases, yeah. Base and height of the triangles. 6 and 7, yep, so it's got a base of 6. There's our right angle, 7. So 6 times 7 divided by 2 is the area of a triangle. But then I'm multiplying by 2 because there's 2 of them, so that piece cancels out, leaving us with 42, right? All right, so looking at our rectangles then, if I jump back up here, so this side length, hang on, let me change colors. This side length here is 6. None of the other short sides of the rectangles are labeled, so we're assuming they're all 6. So our rectangles are going to be what? All 3 of them are going to be 6 by 15. So we're going to have 3 times 6 times 15. Olivia?
270.
Excellent, which is 270. So then once we have that piece, we've got our triangles and our rectangles. All we're going to do is we're going to total it up. So 42 plus, 270, 312 centimeters squared. Zoom in, give you a second to make sure you've got that copied. And then if you have questions, you're looking back through it and you're like, I don't know where you're getting these numbers from, let me know, we can run down the example. All right, last one. Prism shown below is wrapped for Christmas. It says, how many square inches of wrapping paper will Mrs. Harris need to wrap the prism? So looking at this word problem, am I looking for surface area or volume?
No, surface area.
Volume is how much I can fit inside. Surface area is how much around the outside. I am not filling this present with wrapping paper. That would be silly. I'm covering it with wrapping paper, which means it's surface area, yes. Okay, so let's do the same thing. Here's what I'm going to do for this one. If you're somebody who's sitting there and you're like, okay, I feel like I kind of understood what we did for those first 2. You want to attempt this one on your own, go ahead and start that. If you're like, ooh, I'm still not quite sure, or I'm not quite there yet, that's okay too. We're going to give the people who are working on their own about a 30-second head start, and then I'll start walking you through this one, okay? So if you want to walk through it with me, hang tight. If you're feeling good, you can go ahead and get started on your own. All right, if you want to walk through this with me, here we go. If you're working on your own, you can continue working on your own. I'm going to start again with my, triangular bases. So I've got 2 of them. They have a base and a height of 4 and 5. So again, here's our height, the 5. It forms the right angle with that side length, which is 4. So 4 times 5 divided by 2 times 2 gave me 20 for both of those triangles. And then same thing with these rectangles. We can see that only one short side is labeled as 4, which means all of these rectangles are going to be the same, which means I have 3 4 by 9 rectangles, right? Which is 108 when you multiply that together. 3 times 4 times 9. When I go ahead and get a total of that, I'm going to add 20 and 108, which gives you 128 inches squared. Questions on that? Those of you that attempted that one on your own, how did we do? Good. Good. So next week when we get together, we're going to have pyramids is going to be the last piece that we look at. Pyramids are pretty much the same exact process of finding the areas of all the pieces and combining them. It's just a little bit different because you no longer have the two bases. You've only got that one base and then those triangular sides, right? So that's where it makes things a little bit different, but same process that we'll walk through. Okay? You can go ahead and start cleaning up your things.